If a strip of a copper metal is placed in a solution of ferrous sulfate, so what will happen? You have a solution that contains the ferrous ions and we have the sulfate. The question is, if you put some copper metal in it, so the possibility here is that the copper may lose electrons, the copper metal may lose electrons to the iron, means that the copper can lose electrons, gets oxidized, and the iron ions in the solution Fe2 plus ions may gain those electrons and form the iron, the metallic iron. That means the copper will now here act as the anode and this iron will act as a cathode. But this is only possible, see, this reaction is only possible when you have the iron, its reduction potential is more than the reduction potential of the copper. The copper can lose electrons only to the metal whose reduction potential is more than the reduction potential of the copper. And if you look at the electrochemical series, the reduction potential of the copper is about 0.34, while as the reduction potential of the iron 2 plus ion is minus 0.44, which means that the reduction potential of the copper is higher, means copper has high tendency to gain electrons than the iron, right? So means copper cannot lose electrons to the metal whose reduction potential is less than the copper. So that means this reaction is not possible. This is not a spontaneous process. Copper cannot lose electrons to the iron because iron, its reduction potential is less. Its tendency, the tendency of the iron to gain electrons is much lower than that of the iron, or that of the copper. So copper cannot act as an anode. Rather, if you do the reaction in a reverse way, means if you suppose take a copper sulfate solution and then you put the iron metal in it, there the copper will gain electrons from the iron because copper has higher reduction potential, and we have learned that the EMF of a cell is actually the reduction potential of the cathode minus reduction potential of the anode, and the cell reaction is only possible when the EMF is positive. If the EMF of the cell is negative or it is zero, the reaction is not possible. And this EMF can be possible positive only when the reduction potential of the cathode is higher than the reduction potential of the anode. So only then the reaction is spontaneous. Otherwise the reaction is not spontaneous if the EMF is negative. For this cell, while you see that this possible reaction that we have written here, the reduction potential of the copper and the iron, if you subtract the cathode minus anode, it will be in the negative, the value. So that means the reaction is not possible. The iron cannot act as a cathode. It cannot take electrons from the metal who has much actually higher tendency to gain electrons, right? So the copper cannot lose electrons to the one whose reduction potential is lower. Rather, copper can lose electrons to the metal it can lose electrons to the silver ions. If you take a copper strip and put it in a silver nitrate solution, there you will see the copper will lose electrons to the silver ion because silver has higher tendency to gain electrons than the copper. Here the the silver will act as a cathode, the copper will act as an anode, and the EMF in this case will be positive, but not over here. So that means the option D is no reaction will take place here because the copper metal cannot lose electrons to the iron ions. To a mixture containing the zinc, copper and the silver and 1 molar sulfuric acid, hydrogen gas was found to be evolved. Which of the metal do you think has reacted? So the situation is like this. We have a mixture of the three metals. We have the zinc, we have a copper and we have the silver. And we have put it in a solution of this H2SO4 and we have the H plus ions. Now the question is, which metal you think has reacted and we got the hydrogen gas, because from this mixture we have produced the hydrogen gas. And you can see those metals, the zinc, copper and the silver, only the metal whose oxidation potential is much higher than the hydrogen, right, will react with the H plus ions. Means the metal whose oxidation potential, whose tendency to lose electron is more than the hydrogen, will react with the H plus ion. or I can say the metal whose reduction potential is lower than the reduction potential of the H plus sign. Correct? The metal whose reduction potential is less will react with the H plus signs, because the reduction potential means the tendency to gain the electron. Okay, if you have the metal who has, that has higher reduction potential, suppose if you look at the silver, the reduction potential of the silver here is 0.80, and for the hydrogen we know by convention we are taking it 0. For the hydrogen it is by convention the reduction potential of the hydrogen is 0.0 volts. So this is a reference electrode, and those electrodes having higher reduction potential than hydrogen. Suppose silver has much higher tendency to gain electrons than hydrogen. So that means silver metal cannot lose electrons to the H plus ions. It cannot lose electrons to the H plus ions because silver has high tendency to gain electrons than the hydrogen ion. Similarly, look at the copper. The copper, its reduction potential is 0.34 volts, and again this reaction is not possible because the copper has high reduction potential. Now the zinc, this is the oxidation potential, the zinc to zinc 2 plus. So its reduction potential will be minus 0.76, because we know that by changing the sign we can convert an oxidation potential into its reduction potential. So we have here the oxidation potential, now its reduction potential will be minus 0.76. And if you compare it with the hydrogen, you see that this is the lower reduction potential. The zinc has lower reduction potential, or I can say it has higher oxidation potential than hydrogen. So means the zinc will lose electrons to the hydrogen, so this reaction will take place. Only the zinc metal will react with the hydrogen ion. In a simple electrochemical cell which is in standard state, half cell reactions with their appropriate oxidation potentials are given. So we are given the oxidation potential. The oxidation potential of the lead is plus 0.13, and the silver, its oxidation potential is minus 0.80, which means that lead has higher oxidation potential than the silver. And you can convert their oxidation potentials into the reduction potentials. So the corresponding reduction potentials will be minus 0.13, and this will be plus 0.80 volts. So which of the following reactions takes place? Over here you can see the reduction potential of the silver is higher, so definitely it will act as a cathode, and the lead, its reduction potential is less, it has high oxidation potential, it has high tendency to lose electron than the silver, that means it will act as an anode. So means the reaction where silver ion will gain electrons from the lead will be possible. Okay, the reaction that where you see the silver ions taking electrons from the lead metal, because silver will be reduced, it will act as a cathode, and the lead will act as an anode here. So means the option C is correct one. The silver ions will take electrons from the lead, because now the lead is being oxidized, this is oxidation here, and the silver is being reduced, so this is reduction here. So this is the cathode. So option C. When the cell reaction attains a state of an equilibrium, the EMF of the cell is 0, because we know that when this you have a galvanic cell, and the difference in the reduction potentials of the two electrodes, we know the electrode potential of the cathode is higher than the reduction potential of the anode, and the difference is nothing but a EMF of the cell. Okay, the EMF of the cell, or the cell voltage you can say, is the the EMF. And with time we know the reduction potential of the cathode decreases and that of the anode will increase, and a point will reach when both the electrodes will have the same electrode potential, means now this is the state of an equilibrium. And now when you attain a state of an equilibrium, the reduction potentials are same, the EMF is 0, that means the cell will not produce any more current. The I2 and the bromine are added to a solution of 1 molar each of the iodide and the bromide ions. Which of the following reactions will take place? So we have a situation like this. We have a solution that contains I negative and the Br negative ions, and 1 molar each, concentration is the same, and to it we are adding the iodine and the bromine, right? We are adding iodine and the bromine. So the possibility now is that we may have a redox reaction where the electrode with a high reduction potential will act as a cathode, and the one with the lower reduction potential will act as an anode. The question is, which of the following reaction will take place? and the standard reduction potentials of the iodine and the bromine are given. For the iodine it is 0.53 and for the bromine it is 1.09, which means that the bromine has high reduction potential, so definitely it is going to act as a cathode, it will gain the electrons, and this one 0.53 will act as an anode because its reduction potential is less, because we know the cathode minus anode is the EMF, and the one which has the higher reduction potential will gain electrons and the one with the lower reduction potential will lose electrons. So that means the bromine will be reduced here, and the I negative ions will be oxidized. So I negative ions will lose electrons to the bromine. So I negative ion will actually convert into iodine, and the Br2 bromine will be converted into Br negative ion. The oxidation potential of A and the B are 2.37 and 1.66. So oxidation potential means the tendency to lose electrons. So A has higher tendency to lose electrons than the B. That means A will lose electrons to B. That means A will replace the B from the solution. A metal with the high oxidation potential, the metal which has higher tendency to lose electrons, will replace an ion, a metal from a solution with the having the lower oxidation potential. So you can say the A here will replace the B from a solution because A has higher oxidation potential. So A will replace the B. The standard reduction potential values of the three metallic cations X, Y and the Z are 0.52 and minus 3.03, 1 minus 1.18. So the order of reducing power of these metals will be the metal that has high reduction potential. Remember, the high reduction potential means high tendency to gain electron. Okay, a metal that has a higher reduction potential will have the lowest reducing power. Okay, suppose if you have a metal and it changes into the metal 2 plus ions or 3 plus ions, the tendency to lose electrons is called oxidation potential. And if a metal has higher oxidation potential, means it will be a better reducing agent. It will reduce the other metal, the other ion. So it has higher oxidation potential, or I can say a metal that has higher oxidation potential will have a lower reduction potential also. Correct? A metal that has higher oxidation potential will have a lower reduction potential. A better reducing agent is the one that can lose electrons easily, means it should have the higher oxidation potential, or I can say it should have a lower reduction potential. So among the three, the lowest reduction potential is for the Y, minus 3.03, and then it is the Z and then the X. So the option A is the correct one. Electrode potential data are given, and based on the data, the reducing power will increase in the order. So again, it's the same question. So you can see here the metal with the highest reduction potential. The metal with the highest reduction potential is this one, plus 1.08, the bromine. So it will be the least, the lowest, it will have the lowest, reducing power. And among the three, it is the aluminium that has, the lowest reduction potential, means it will be a better reducing agent because it will have a higher oxidation potential. It will have high tendency to lose electron. So a better reducing agent. So then you can say the order will be for the bromine, and then this will be the iron, and then the highest will be for the aluminium. So it will increase in this order. The standard reduction potentials at 298 Kelvin for the following half reactions are given against steel. So we have given the reduction potential. These are the reduction potentials of the different electrodes. Which is the strongest reducing agent? So again the same question, the one with the lowest reduction potential will be a better reducing agent. So it means it is the zinc, minus 0.76. It has the lowest reduction potential, means it will be the better reducing agent. So among these four, this is the strongest reducing agent. Hope you got it. Thanks for watching the video. Bye for now.